Okay. What we have is our second video on assessment. Number 3 which is on Newton's second law. And I had the problem written down, but I'm just going to summarize it. What we have is a guy that is practicing to make the row team at his school. He's going to a friend's dock, and which is a 3.6 kilometer row. On an average day, it takes him 20 minutes to get to his friend's dock. But on another day, there was a current, and it took him 30 minutes to get to his friend's dock. So what we want to find out is one, the speed of the current, and we want to find this in meters per second, and then also how long it would take the rower to get back to his house when he is going with the current instead of against it. First thing that I wrote out is BW is going to stand for the velocity relative to the boat to the water, and BC is going to be the velocity relative to the boat and the current. The first thing I did was I converted 3.6 kilometers to meters. So I got 3.6 kilometers equals to 3,600 meters. I then took our times of 20 minutes and 30 minutes and converted them into seconds. So 20 minutes equals to 1,200 seconds, and 30 minutes equals 1,800 seconds. What I then did is I found the velocity of the boat without the current first, which I did the velocity of the boat relative to the water is 3,600 meters divided by 1,200 seconds. We get 3 meters per second. And then when the boat was going against the current, right here, we have 3,600 meters divided by 1,800 seconds, gives us 2 meters per second. To find the velocity of the current, I then subtracted the velocity of the boat relative to the water minus the velocity of the boat relative to the current. So the velocity of the current is 3 minus 2, which gives us 1 meters per second. And then, like I said, we also wanted to find the time that it took the rower to get back to his place when he was flowing with the current. So we know that without the current, it would take him 20 minutes. He'd be going 3 meters per second. And then when he's going with the current, you add another meter per second, because we found out the velocity of the current is 1 meter per second. So in total, the rower, to get from his friend's dock back to his house with going with the current, takes 4 meters per second. I then did velocity equals the change in displacement over delta t. And then I solve for delta t, so we get change in displacement over our velocity. And so we get delta t equals 3,600 meters divided by 4 meters per second. We give it a time of 900 seconds. And then to go back to our original units, I found 900 seconds divided by 60 gives us 15 minutes. Again, this is the assessment for our fourth assessment, which was on Newton's second law.